Welcome to The Explainer. Today we're diving headfirst into the wild, dynamic, and honestly, sometimes downright treacherous world of seaplane aviation. If you've ever watched a seaplane touch down on a pristine mountain lake or a busy city harbor, you already know it's an incredible sight. But as we're going to see today, operating an aircraft on the water, it is fundamentally completely different from touching down on a paved, static airport runway. We are going to break down the unique hazards, the intense operational standards, and the frankly incredible high-tech future of water aviation. So think about this for a second. What actually happens when your runway is constantly moving? It's so easy to look from the shore and think, wow, what a peaceful, controlled glide. But we need to challenge that illusion right now. Because the reality is water surfaces are never truly static. When your landing strip is constantly shifting, changing, and reacting to massive environmental forces, every single takeoff and landing becomes a highly complex, highly fluid equation. When you really look at a water landing up close, you see the chaotic, splashing reality of contact. There is intense wake, drag, and splash. Pilots aren't just casually flying the plane down, they're instantly managing a literal collision of physical forces. They've got to account for variable winds, totally unpredictable wave conditions, and the immediate heavy drag of the water grabbing at the pontoons. And depending on the wave state, whether it's just light chop, moderate rolling waves, or a tricky crosswind, the aircraft behaves completely differently. Even the tiniest environmental shift demands intense pilot awareness the absolute millisecond those floats hit the surface. Now here's something totally counterintuitive. You'd probably think that perfectly flat, mirror-like water is the absolute dream scenario, right? Well, actually, extremely calm water creates what aviators call glassy water conditions. It acts like a giant mirror, completely stripping away all the visual texture and reference points that a pilot naturally relies on. Without those visual cues, judging your exact altitude accurately during a landing becomes incredibly difficult. It turns this perfectly peaceful-looking summer day into a massive hidden hazard. It's a lot to handle. Sure, massive waves can literally damage the plane's floats, but even on a decent day, pilots are constantly crunching the numbers on a whole matrix of shifting elements just to stay upright. You've got wind pushing the aircraft from above, while waves, fast currents, and tides are pushing and pulling the floats from below. Add in changing visibility from sudden fog, rain, or low clouds, and you have an environment that requires 24/7 active assessment. Turning a seaplane on the water isn't like turning a steering wheel in your car. It's this delicate, constant dance between engine power, rudder control, wind direction, and the movement of the water itself. Section 1. Surviving harbor chaos, from sky to dock. Imagine touching down and suddenly you are navigating a fluid highway filled with a rapid-fire obstacle course. There's no standardized runway lighting or painted lines leading you safely to the gate. Instead, you're taxiing right alongside massive passenger ferries, unpredictable private speedboats, deep-draft cargo vessels, swimmers, and sometimes even floating shoreline debris. You're basically dropping an aircraft right into the middle of a busy marine traffic system. It requires a total mental shift from an aviation mindset to intense maritime awareness. You drop right into these tight, incredibly crowded maneuvering areas, and the collision hazards become obvious immediately. To get safely to the dock, the pilot has to essentially thread the needle. There are docking crews waiting, visual hand signals flying around, and just a sheer, dense wall of vessels. You have to coordinate your engine bursts and rudder perfectly, just to park the thing near giant buoys and ferries without drifting straight into a concrete shoreline. And getting to the dock? Well, that's a whole other high-stakes puzzle. Why? Because your parking spot is literally floating. It's a moving target. Unlike conventional fixed airport gates anchored deep into concrete, floating pontoons and docks are constantly shifting, rising, and falling with the tide and the heavy wakes from passing boats. Aircraft drift during docking is a major, major hazard. It means the pilot is essentially still flying the plane right up until the exact moment that rope is securely tied to the cleat. Section 2. High-stakes emergency response when the runway fails. Let's flip the script for a second. Contrast a standard tarmac emergency with a water emergency. On land, if a plane has an engine failure or blows a tire on landing, emergency fire trucks and ambulances are rolling up on paved access roads in seconds. But on the water, an emergency instantly demands a completely different set of survival skills. We are talking immediate cold water survival procedures, deploying complex flotation systems, and initiating massive marine recovery operations. The environment itself becomes hostile to the passengers the second they step out of that aircraft. If you look at the timeline of an incident, surviving a rough water crash demands this intensely coordinated, multi-agency sequence to get people to safety. It kicks off with the initial distress alert, then dispatches rescue boats and helicopters, moves to complex on-scene air and sea coordination, and finally ends with the physical, difficult evacuation of passengers directly from the water. Seeing that massive air and sea response in action really drives home a tough truth. Yes, rapid response from Coast Guard vessels and rescue choppers is totally critical, but your absolute first line of defense is right there in the cabin with you. It's the life jackets, the emergency beacons, and the cold water protection gear. Preparedness and safety drills are what actually save lives in those crucial minutes, long before you ever hear the chopping of helicopter blades. And this is exactly why that preparedness isn't just a suggestion, it is everything. A lot of these seaplanes are flying out to extreme remote environments, way out in the wilderness, far from those bustling harbors we were just talking about. In those areas, weather forecasting can be spotty, and if things go south, it might take a significant amount of time for rescue services to reach you. Because of that, operational discipline is everything. Pilots absolutely have to meticulously evaluate weight, fuel, and weather before the engine even turns on. Survival really does depend entirely on rigorous preparation. Section 3, the Smart Seabase Future, bringing data to the water. Okay, let's lighten things up and look ahead. We're right in the middle of this incredible technological transformation. We are rapidly moving from an era built entirely on a pilot's manual skill and visual judgment straight into one supported by highly integrated command centers and predictive safety networks. We're talking autonomous drones monitoring weather patterns, digital data networks tracking every boat in the harbor, and smart docking systems designed to automate the most hazardous parts of parking these planes. These smart tech upgrades are basically acting as a massive digital safety net. By combining AI-assisted navigation with digital marine overlays, pilots can essentially see underwater currents and boat traffic way before they become a visual problem out the window. Things like autonomous hazard detection and real-time weather analytics are huge for risk management. They continuously monitor the environment, stepping in to help pilots make safer, faster decisions in conditions that would otherwise be wildly unpredictable. Of course, you can't just rely on robots and sensors. Behind every piece of tech and every rigorous training drill is a massive interconnected web of global agencies. You've got the FAA and Transport Canada writing the rules for water aerodromes, the ICAO and NTSB setting global standards and investigating incidents, and NOAA feeding everyone vital marine weather data. It is a huge, highly coordinated global effort working around the clock to keep water operations safe. So if there is one crucial takeaway from this whole explainer, it really boils down to this profound idea. Successful water aviation is not simply about flying an aircraft. It is this incredibly unique, highly specialized blend of aviation knowledge and intense maritime mastery. These pilots aren't just aviators, they are expert mariners. They have to read the water, feel the weather, and predict the traffic, all at the exact same time. I want to leave you with a thought. Knowing all the massive fluid complexities these pilots navigate every single day, the literal obstacle courses they run, next time you see a seaplane, are you just going to look up at the sky? Or will you watch how the water is moving beneath it? Hopefully this explainer has completely changed how you'll view these incredible machines from now on. Keep learning, keep analyzing, and I'll see you next time.